Good day, everyone. I am Jennifer Bahandi, Visabi 2A, and I am assigned to discuss about Module 3, Curvilinear Translations, and Lesson 1, Flight of Projectiles, Air Resistance Neglected. Translation of the rigid body has been defined as motion, in which a straight line passing through any 2 points are still parallel to its initial positions. This definition requires that all particles of the translating body have exactly the same motion. Hence, in discussing curvilinear translation, the body may be assumed to be able to concentrate at its center or gravity, which is, pwede nilang ma-treat ito as a particle, just like in the case of rectilinear translation. So now, I will continue discussing about the lesson 1, Flight of Projectiles, Air Resistance Neglected. But first, I will define about projectile. When we say projectile, it is any body that is given as an initial velocity, which is, it can follow the path that can determine the effects of gravitational accelerations and air resistance. While, when we say air resistance, it is always in the opposite directions of projectile and velocity. Especially in any motion, it is always in the opposite direction. And also, the path followed by the projectile is called its trajectory. So, we shall assume that the projectile moving without any rotation in a vacuum. Those factors are 1. Velocity, air resistance, and rotation of the Earth, which have an effect on the actual flight of the projectile will be neglected. The principal solutions is to resolve the curvilinear of the path into rectilinear motions along the x and y axis. So, in this moment, I will continue discussing about the graph given by the module. Let the path of the projectile be given by the curve O, B, C, and D, with the origin of axis at the initial point of flight. So now, the initial velocity is taken as VO. It is directed at an angle theta with the x-axis. So from the initial direction of motion, this placement will be taken as positive both rightwards and upwards. So since the only focus acting on the projectile is its own weights, its total accelerations, and all positions is due to gravity, and sometimes it is directed vertically downward with the value g. So hence, the rectangular components of the accelerations are constant at a sub z equals 0 and a sub y equals negative g. Instead of considering the actual flight of the projectile, we will combine it simultaneously projections upon the x and y axis. Those equations of rectilinear components are found by substituting the x and y components of s, v, and a in the equation for the rectilinear motion with constant accelerations in applying that table. So, if this is the continuation about the graph, if the time of the flight is less than that the required to reach the sea, and then the projectile will be above its initial positions and the values of y displacement will be positive. While if the time of the flight is more than that the required to reach the sea, and then the projectile will be on the path CD, after that, the values of y displacement will be negative. So, at the topmost point of flight B, the value of v sub y will be 0.